Hi everyone, I am Yamini, Department of Computer Science and Engineering, SNS College of Technology. Today we are going to discuss about MST. MST means Minimum Spanning Tree. Minimum Spanning Tree, there are two types of Minimum Spanning Tree. First one is Prims, second one is Kruskal. These informations are explained with my maybe so that's a group discussion.
So, good morning everyone. As ma'am said, in this session we will be discussing about the major topic which is most important, which is nothing but the minimum spanning tree MST. So, minimum spanning tree is nothing but a subset of tree which is in a connected, weighted and undirected graph. So, the main properties of the minimum spanning tree are that it has no cycles and also contains v minus 1 edges. That is, here v is nothing but the vertices. If the vertices is given as 5, then the edges will be 4. And the last point is that it helps us to find the minimum total weight of the given tree. So, in order to find the minimum spanning tree, there are of two algorithm methods. The first comes the Prim's algorithm and the next is the Kruskal's algorithm. So, further, this Prim's and Kruskal's algorithm will be discussed with the example by us.
Hello everyone. Now the Prim's algorithm are explained by me. Prim's algorithm is a greedy algorithm used to find minimum spanning tree, connected weight, and undirected graphs. It starts from single vertex and adding the minimum number of edges. It is a Prim's algorithm.
So the basic example is given here. So it's a Prim's algorithm where A, B, C, D are the vertices and here the edges are given between A, B, B, C, C, D, A, C and B, D. So here we are drawing the topological chart table. So here V is the vertices and here known dV is nothing but the distance, P is the path. So by following further steps, we will be first looking into the shortest path A. So A goes to the path B and D. So in order to that, we will be making A as true and we will be writing in B as A and D as A because B and D comes from the path A. So by following this order repeatedly, we finally come to the conclusion that all the values of the node becomes true and the final distance can be found that the MST edges which are given are AB, BC and CD and the total weight is nothing but adding all the dV values 1 plus 2 plus 3 which is nothing but 6.
So the algorithm, it is a minimum spanning tree MST algorithm to find a subset of edges which connects all the vertices in a graph and it doesn't have a cycle between it and it also helps to find a minimum possible total edges weight.
So here is the example of Kruskal's algorithm. These are the vertices A, B, C and D. These are the shortest edge path which is 1, 2, 3, 4 and 5. Among these we should select the smallest edge path. So from vertex A to B it is 1. So first step we should be drawing this A to B as 1 and the second shortest path is 2. So next one from A to C we will be drawing the 2. And if we taken the vertex B and C, it is 3 and it forms a loop. So we should avoid it and we should take the next number. So C to D, that is 4, and from A to D it is 5. So you should avoid it because it forms a loop. And at last we should add all these 4 shortest edge path, which is 1, 2 and 4. So the final answer is 7 for this example.
So in the conclusion, we have discussed about the types of minimum spanning tree which is nothing but Prim's algorithm and Kruskal's algorithm. So Prim's algorithm was explained by Narmada and the further example has been also explained and also the Kruskal's algorithm was explained by Nisha with the help of the Hema. So in this, so what's the conclusion is that if a common tree is given, if the common graph is given, the answer of both the Prim's and Kruskal's algorithm must be the same. So if we get the answer for Kruskal's algorithm as 6, then the Prim's algorithm answer would of course be 6 because these both were same, which gives us the minimum total weight of the graph what we have given. Also we must be very cautious of checking whether a loop is formed in the Kruskal's algorithm. So comparatively for Prim's algorithm and Kruskal's algorithm, we think that it is more preferable to move with Kruskal's algorithm in order to avoid the mistakes what we do often. Whereas in Prim's algorithm, we must be cautious of writing the values of dv and pp. So it is better to move with Kruskal's algorithm. So finally, we have concluded the main key points of minimum spanning tree with excellent examples. I hope that you have understand better. Thank you.
My mentee students have discussed about MST with group discussion. Your presentation is very nice, explanation is very good. More completion of work is very good.